you guys should be working on your do now and make sure that everybody wrote down the homework. We're going to check last night's homework while you are working on a graph in a little bit. Okay, so take 1 more minute for the do now. Finish it up. Okay, so today we're talking about if populations can grow indefinitely. What does that mean? What does indefinitely mean? Jillian.
Grow forever.
This Jillian. My eyes.
More and more and more and more and more.
Just grow forever.
Infinity.
Exactly. Okay, so we're going to see if populations can grow indefinitely. Okay, so how many squirrels do you think live on our school's campus? Just an estimation. Jackson, what do you think?
Well, it sounds like a lot, but I was thinking like around like 80.
Okay.
Because thinking that like if they live in groups of 10, maybe like 8.
Okay, sure. 8 families of 10. This I'm less concerned about. This is just your estimation. It doesn't matter what you put. I'm more concerned with number 2. What determines how many squirrels can live on our school's campus? All right.
Do you know of trees on the campus?
Okay, so the number of trees, definitely. Because what are we getting from the trees? What are the squirrels getting from the trees? Julian.
Other resources that they would just around.
So what resources specifically?
Like I guess nuts and
Okay, so food, and what was the other one?
home.
Shelter. Habitat. Okay, what else would determine how many squirrels? Yeah, Julian.
Competition.
Okay, competition with other species. What did we say yesterday? Decreases competition. Look back at yesterday's notes. What decreases competition? Jackson. Niches. So if there are more niches for the species on campus, then can we have more squirrels or less squirrels? If there are more niches, can we have more squirrels or less squirrels? Amanda? More, right? So more niches equals more squirrels. So the amount of niches in the environment could affect this. Okay, so all of these things, also water. Availability of water. Is it a dry season? Is it a wet season? All of these things, we call them limiting factors. What do you think they're limiting? Water, food, shelter, competition. What do you think these factors are limiting? Jillian, what do you think?
Life and life expectancy.
Life expectancy, population. Okay, so these factors limit the size of population. So these are factors in an ecosystem that limit how large any given population can get. And it's based on their absence or presence of these factors. For instance, if there is a lot of water one year, how will that affect squirrel populations? If it's a really wet year, what will that do to the population? Mikey?
Well, it could make them grow because there'd be more water to drink. But
More water to drink, more food, so it makes population go up. So limiting factor, if water is high, then population can go high. If it's a dry year, what will that do to population? Yes?
It would decrease because there's less water.
Right, so it's a limiting factor. Okay, it's a limiting factor. Water goes down, population goes down. If there's a lot of food, population goes up. There's a limit, okay? We're going to talk about, when we get back from doing this activity, the limit. So population can go up, population can go down. That number that it goes up and down to is called the carrying capacity. So we're going to look at that through an activity. Okay, so this lesson is really about this definition of carrying capacity. So please listen to the directions of the activity. We're going to be going out near the cafeteria in that little lobby area. Okay, please listen. We're going to have 2 lines. One line is going to be deer. The other line is going to be resources. The resources that the deer needs are water. Okay, so do this for water. Agua. Do this. Water. Food. Comida.
Yes. What is comida?
Plants are food for deer. And shelter. Casa. See? Okay. So you can every year you can be water, plants, or shelter. Okay, so this is how it's gonna go. There's gonna be deer over here, resources over here. Every year, which is around, the deer walk over. If the deer gets a resource, that means the deer survives, reproduces, and you both become deer for the next round. If the deer walks over and there are no resources left, then the deer dies, decomposes, and gets recycled into resources. Okay, we'll play this for a few rounds. After a few rounds, a wolf is going to migrate in, and we'll talk about the wolf when it gets here. Okay, yes. Questions? I mean, not questions. Whose birthday is in May? Okay, you guys are going to start as the deer, but it switches every time. Okay, so it switches. When's your birthday in May? My birthday's in May too. Not one of those days. Okay, so you guys, it's going to switch all the time. So leave everything here. You don't need anything with you. We're just going to go right by the cafeteria, right near the stairs. Deer, walk over, get any resource. If you get a resource, then both of you become deer. Okay, so, and I'm going to take data every year, so I have to count. So don't move until I tell you guys. Okay, walk. Make a resource. Touch the resource, and then you both become deer. Okay, line up. Get in line, right on the black line. On the black line. It goes all the way across, guys. Okay, make a resource. Line up so I can count. Here are the rules for the wolf. Guys, move over. Here are the rules for the wolf. Every year, the wolf can get one deer only when it's walking this way. You guys have to walk in a straight line. Do not try and sway around. There's not enough room here. If you get hit by the wolf, you become a wolf. If you don't get hit by a wolf, you can still try and get a resource. Got it? Okay. So, walk. Everybody go. Walk. Okay, wolves, come over here. If you're a deer and you don't get a resource, you die and become a resource. Oh, great. No, somebody did something wrong. Okay. Everybody, walk. Walk. Walk.
With me.
If you die,
I got Juliet already.
if you didn't get anything, you died. Go over there. If you didn't get anything, you died, and you go over there. Wolves, go over here. Jackson. Walk.
I'm dead.
Javier, you died. Sorry. You're a resource. Guys, spread out. Line up over here.
Can I run?
No. Spread out over here. Wolves, go over here. I can't tell who you are. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Stop. Resources, move down. Javier, everyone move down. Okay. Walk. Okay, if you die, go over there. Become a resource. Yeah.
We both died.
Okay, wolves, go over here. Wolves, go over here.
I must have looked at Are there no deer?
You get something?
Okay, so that's it. Oh, I'll turn it around. We're gonna go back and we're gonna graph the data. Okay, you guys ready? Quiet in the hallways, no talking. Let's go. To the data table. On the outside, put year, resources, deer, wolves. And then we did 6 years, so number 1 through 6. Okay, I'm gonna write the data and you guys can copy me as we go. And then we'll talk about the graph.
Miss Brown, you have to move. You're in front of it.
Oh, okay. Okay, I'm going to put the data back up in a minute. Let's explain what we're going to do with the graph. I'll put this back up in a minute. Okay, what you guys are going to do, I'll put it up in a minute. We're going to graph this. We're going to do a triple line graph. Don't copy it yet. Please listen and then you can copy it in a minute. Okay, so we are going to be graphing. Which of those numbers? You guys have 4 numbers. You have the year, the resources, the wolves, and the deer. Which is independent variable? Which one does not depend on any of the other numbers? Year, population of resources, population of deer, population of wolves. Which one is independent? It's not affected by the other numbers. Amanda? The year. The years would go on anyway. Does it matter how many resources there are for it to go another year, right? So where does the independent variable go? The x-axis or the y-axis? Where do independent variables go? The x-axis. Okay, so down here will be year. So you'll number it 1 through 8. On the side, on the y-axis, will be number of individuals. And this can be resources, it can be deer, it can be wolves. Doesn't matter which one. And this will go up to 16. Okay, you're going to do 3 lines on the same graph. So somebody tell me, year 1, how many resources were there? Year 1, how many resources? Guys, you're not working on this right now. We're listening to instructions right now. Everybody put your pens down and listen. Put your pens down and listen. How many resources year 1? Michelle, how many resources year 1?
Already individual.
I'm just asking, how many resources year 1?
14.
14. Okay. So, how many resources year 2? Jorge.
12.
12. Okay. And so on and so on. So wherever 12 is. Then you're going to do 1 line that shows the resources, and you'll do a key. Blue equals resources. How many deer were there year 1? Maggie?
2.
How many deer year 2? Yes?
4.
Okay, and so on and so on. And then you'll do your graph for deer. Then you'll start your wolves at year 3 with 1 wolf, and you'll do your wolf line. Okay, so 3 lines, same graph, 3 different colors. Do the dots, always do the dots, and then you connect the dots after you've done all the dots. Do all the resources first, draw the line. Do all the deer, draw the line. Do all the resources, draw the line. Questions? Okay, so I will come around, grab 3 colored pencils. I will put the data back up for those who need it. Okay, grab 3 colored pencils. 3 different, very different colors. That's not different enough.